Yes, after this exquisite announcement, there is no need for me to introduce myself. So let's just go straight to the title of my talk. It is Superpowers for tailoring asynchrony, or how to customize your coroutines, or how to abuse the hell out of coroutine context. So today, I know it is late, so probably you are after a long day of networking and attending or maybe giving talks at this conference, or maybe you are from the group that came here just for KotlinSphere, so probably you are after a long, tiring day at work. So I don't want to give you some technical, full of details talk. I want to tell you a story, a made-up story that will of course contain some bits of Kotlin. And I hope these bits of Kotlin may help you change your perspective on some things and maybe give you some insight or inspiration to try different way of thinking about problems we are solving every day. So this made up story, let's begin it. Let's imagine we live in year 2219. We work as a team of Kotlin developers. Yeah, Kotlin is still alive and well in 23rd century. We are doing outsourcing project for some extra dimensional being. So yeah, cost of work here on Earth are so quite low. So there is no wonder that in 23rd century, Earth quickly became outsourcing center of the whole multiverse. And this project are some complicated calculations that we are running on something that is called octahedral hypercluster. So our story begins when we came to work one day, and one of our colleagues, he is quite inexperienced Kotlin programmer, has some problem. Yesterday, we assigned to him task for designing the system for notification about progress, for monitoring progress of our asynchronous tasks that will be created to run on this hypercluster. But he seems to be stuck. Let's call this inexperienced junior Kotlin programmer Andrew. So Andrew is coming to us and is showing us his code, and he's saying that he's lost in all this boilerplate because he doesn't know how to pass this progress monitor from one asynchronous task to the other. So we are asking him, so did you try passing this as coroutine context? Is coroutine what? You know, these things that you can pass to all coroutine builders, for example, like dispatcher, coroutine names. This stuff. So this strange parameter things that sometimes is dispatcher, sometimes is debug data, and sometimes it is this strange addition thingy. Yeah, exactly this one. So you know you have to start with basic. So you take Andrew and explain for him what coroutine contexts are and what they're used for. So you start with how we normally interact with them. So you tell him that normally they are passed to coroutine builders as a first parameter of the builder. So like in this example, here we have a launch coroutine builder, and it is accepting the IO dispatcher as its coroutine context. Here we have some async builder that is accepting coroutine name with this name as its context. Okay, so now about this strange addition thingy. So contexts can be combined with each other using plus operator. So in this example, we have one coroutine context here, it is IO dispatcher. We have other context here, it is debug data, so coroutine name. And we can use plus operator to combine it into one bigger context that have all information of the first and the second one. Okay. Single context element is context itself. So in every place when a coroutine context is expected, we can just pass single coroutine context element. We've seen it in the first example when we just take one dispatcher, it is one coroutine context element, and we pass it to the function that is expecting whole context. And most important, what coroutine contexts really are. They are type-safe heterogeneous map. So you started to explain what type-safe heterogeneous map means to Andrew. So you started from the right. The map is something that has keys and values. Coroutine context has keys and has values. For every key, there is exactly always one and exactly one matching value. What does it mean that is heterogenic? It's heterogenic because it can hold value of multiple types. So for example, you can put in single map dispatchers and some debug data like coroutine names. What does it mean to be type safe? It is type safe because when you are extracting element from coroutine context, you have all information about its type during compilation time. And if you are not doing something strange, for example, like providing your own implementation of coroutine context that is not complying with contract of coroutine context, or doing some strange reflection things, you are 100% guaranteed that your code will be safe without needs of any type checks or typecasting. So let me show you this in practice. So here we have interface coroutine context. The only thing that is important for us is this get operator. Of course, this code is slightly simplified. For example, I removed type bounds here because they are not so important. As we can see, this get operator can return different types for us. The E is generic type. So where information about what E is comes from? We see that is used in key. So all the information about type of T that we are extracting from context is coming from this key. So it means that each key has the type of the data it can extract from the context. So for example, if one key can extract only continuation interceptors, it is key of continuation interceptors, it can only extract continuation interceptors. If it's key of coroutine names, it can only extract coroutine names here. So how the key looks like. The key is only marker interface, it doesn't have any methods. So here we have quite standard implementation of key. It is here. It is key of coroutine name in class coroutine name, which is one of element kind. And as you see, it is defined as companion object. So we can actually use name of this class to get to this object and extract coroutine name. In this example, it can be used like this. So we are taking coroutine context from the scope. Here is the get operator. Here we are passing our key. It is resolved to companion object. We know that our key is of type coroutine name. So this will return optional or nullable coroutine name. It may be coroutine name if it's present in given context, or it will be null if given context have no information about coroutine name. So now back to Andrew. You are looking at his code about this progress monitors, and it looks something like this. Yeah, quite reasonable code. So each progress monitor has its name, amount of work currently done. You can report additional work that has been made to this progress monitor. It is added to current amount. It can never be more than 100%. So that's okay. So now you have to try to help him transform it so this progress will be proper coroutine context. So how you do that? It looks like this. You just add information that this class is implementing coroutine context element. It has one method that you have to implement. In this example, it is called always. It is called key, and it is expected to return the key for this element of the context. It is needed because when you are adding element to the context, it needs to know under which key it has to assign itself. So we are doing standard stuff, like we are using object key that is defined as a key for progress type, and it is also companion object of this progress class, so we can just use it using this progress class name. So how it is look in use? Something like this. You have here you are here launching coroutine. You are passing this progress as a context. You are doing some initial work in this coroutine place of this comment, And here you are reporting that you have done some progress. You are extracting using your key. Okay, then you are doing some more work, and yet another time you are reporting some progress. And Andrew quickly realized that if coroutine context are passed from parent coroutine scope to children coroutine scope, so in other way, if you spawn one coroutine from the other, it will inherit its context, that you can do something like that. So for example, here, you are doing some initial processing in this main coroutine, then you are spawning child, which in a loop is also doing some work and is reporting some small progress every once in a while, every iteration of the loop. But you see, this progress is actually this one. This coroutine is not adding any its own progress monitor here, so it inherits it from the parent. And this gave Andrew some idea. He's looking at you and saying, what if we do something with a wow effect? Something like we do not simply linear one-dimensional progress bars. We do multi-dimensional progress bars. And you are like, what do you mean by that? Like tree of progress bars. So once you spawn a subtask, it has its own progress bar, and it fills up when it's doing work, and this work is affecting its parent, and you see it like a tree structure. Okay, we can try to do that. So you modified slightly your progress class. Now it has private constructor. You've added a few additional properties. For example, pointer to parent. So top level progress does not have any parent, and other children have some pointer to parents. And also you're adding property that is describing the amount of work in parent that this child is doing. So for example, if one child is doing 25% of the work of the parent, after this child finish, the progress the progress bar for the parent should be 25% further than it was when this child was starting. Of course, if there's no any other source of work done. So we've also added some method to do some handy way of creating new subtasks like children, and few other methods, but they are not interesting, and we've done some changes in existing one. For example, we've added method to create top level. So how does it look right now? So right now you can do something like that. You have yet another time one main task. You are doing half of the work of this task here. And then you are spawning to subtask. One is here. It's called subtask 1, and it has 25% of the work inside of it. And the other is here with also 25%. This task are doing some work, and of course they can spawn their subtask. The second task is doing the same. So you run it, and it looks like this. When half of the work in first task is done, 2 additional tasks are spawning. When they are doing their work, it is transmitted to parent. Of course, after scaling, they are spawning more and more subtasks. And this is not just like fancy animation. It is real output of the terminal, because I wrote this preparing to this presentation. I created actually this system of monitoring progress in subtask, and it actually works. It is pretty usable. But when you show this code to the Andrew, he is not impressed, because this code is really ugly. For example, you've got this long repetitive line. You are repeating it 3 times. It seems really boilerplate and unnecessary. You've got this pesky exclamation mark to handle nullability issues. Even such simple operation as reporting progress is something that is quite lengthy, and you actually should, for these progress monitors to be any useful, you should report progress as often as you can. But here it is just quite of long, and copying it is not so fine solution. So, to mitigate this problem, you present to Andrew a free extension that can be added to improve aesthetics of this code. So first one is just getting progress from this coroutine context. If it has progress in this context, it is this progress. If it don't have one, it is just no. You are adding a utility function extension of coroutine scope that is declaring new subtask. It is also taking progress. If it's null, then it is doing nothing, not modifying in any way context of the coroutine. And yet another quite nice plus assign operator for progress. So you can just add done work to this progress. And of course, it also have to handle nulls, because in given scope there may be no any progress defined. So our code now looks kind of nicer. When we are doing some progress, we just add it to it. We can write something like this, which feels kind of natural, that you're launching subtask with given name and with given value. For me, this code is quite intuitive, but not for Andrew. He still has a lot of doubts, because like we are here cheating somehow, because we don't know if given scope, if given context is containing any progress monitor. So we all here have to handle these nulls and doing some stuff like do nothing context, modify nothing context when there is no progress, or for example report but actually not report any progress because there is no progress monitor you can report to. So he's asking you, so can we do it the better way? For example, like write some wrappers for async and launch. Let's call it launch with progress, async with progress. That in this body, they will not have as receivers ordinary coroutine scope, but something that has guaranteed to have progress defined. So for example, something like coroutine scope with progress. Yeah, you answer, of course you can do that. That may be useful, but try to look at it a different way. Because imagine that we have some really simple task that we will be doing many times. For example, asynchronously reading contents of a file. So sometimes probably you want to do that and give user some feedback about progress of it, if it's, for example, very large file. But in other cases, and those cases are most numerous, you don't want any feedback, or you don't need any information about progress, and you can just run it, and it will run itself in background, then finish, then it'll be okay. Or even maybe sometimes you will have some use cases when you are running it synchronously. So there are other places when this progress information will be really useless. And in his solution, the only way to handle that, one of the ways, not the only, but most easy way will be to just have two functions that asynchronously read files. One is reporting progress, and the other is not doing anything with progress. But if we are handling progress like this, so every operation is optional, we can just write one function that is reading file, and it is reporting progress every time. But when it is called in from some context that doesn't have any information about progress monitor, this operation will be nearly to no operations. There will be hardly any cost of them. So, yeah, you seems to convince him. But he is intelligent guy, and he has some other questions about project you are working on. So he starts about dispatching. Yeah. He is pointing out that we are supposed to run our computations on this octahedral hypercluster. And the entry point for this octahedral hypercluster is something that looks like this. There are some node pools, and there is one function that can take runnable and run some code on chosen pool. And we are doing our code in Kotlin, in coroutines. He knows why we like coroutines, but he kind of don't understand how are we going to marry those two technologies, or how we gonna support interoperability between them. So yeah, you see that is quite good question. And you are asking him what Kotlin coroutines are using for scheduling tasks on different threads. So he answered that dispatchers. Yeah, dispatchers. And dispatchers are key here, because this coroutine dispatchers, as we probably remember from the beginning, are passed as an element of coroutine context. It is interesting that they are not coroutine context elements itself. They are inheriting after interface called continuation interceptor, which is so powerful things, and which allows you to do so complex task and has so many use cases that if I had to start talking about use cases of continuation interceptor, I will probably not step down from this stage for the next 2 hours. So I will not go down this rabbit hole. But there is simple implementation for this. It is called coroutine dispatchers, and for nearly 99% of our use cases, coroutine dispatcher is completely sufficient. So, as you show to Andrew, it has one important for us abstract function. It is called dispatch. It takes two parameters. One is coroutine context, and the other is runnable that are meant to be dispatched. So we can create our own dispatcher. So it looks like this. We are creating object called octahedral because we are trying to run on octahedral hypercluster, and our implementation of dispatch is really simple. We are just taking its scheduler and scheduling on some general node pool this block of code that is passed to us as runnable. And it may be strange, but it just works. If we do some code using coroutines and do coroutine that has in this context our new dispatcher, our code will be dispatched. So here we have our dispatcher in the context, and then some printing of thread names and also some asynchronous task. It doesn't make sense, of course, but it's only for presentation. And here yet another printing. So when we run it, we get something like this. So we exactly see that all these print lines was on some node, and on 3 different nodes. In reality, there are even 4th node here. I will explain you in a moment where it was. So you are probably wondering, and Andrew is for sure wondering, that we are writing dispatcher for runables, and we are here not dealing with any runables. We are dealing here with coroutines and some simple code, except this one async. But this code is straight top to bottom. But the compiler is generating these runables for us. So the first one, which we see was scheduled on node 0, is this whole block. Once we are entering coroutine here, this whole block of code is wrapped in runnable. Of course, it's oversimplification because they are continuation and things like that, but I promise it will be rather simpler talk. So there will be few oversimplification here. We can treat that this block is one runnable that is scheduled to run on this node. Okay, here we are doing some asynchronous call. So here it's yet another block that needs to be scheduled, wrapped into runnable and scheduled on its own scheduler. So here we have that yet another thing was scheduled, and this is this print here. So the first node. Then let's go back to the main coroutine. It's encountered await call. Await call is something that is called suspend function. So when it's encountered, our runnable is returning. It is not doing any work more. It is not occupying any thread or any node in node pool. Sorry. It is not occupying any thread. It is somewhere in memory waiting for the notification about that it can run on. So let's go back to the async. This async also executed this line when it was scheduled, and then it encountered its own suspend function called delay. This function also ends execution of its runnable and stores this somewhere in the memory. We should imagine that it looks something like that, and waits for the notification that half of the second has passed. So half of a second has passed, and there comes the notification, and the rest of this async block. So in this example, it may seem that there's nothing here, but actually we have to return value from async block. So send this notification that what is awaiting can now be run. So this is wrapped in new runnable. And if we have some print instruction here, we will see that node 2 is engaged too. So this notification is sent, and our main coroutine is waking up, and it has some work left to do, so it's creating new runnable, and it is scheduled on the node number 3. And that's all. So, yeah. But Andrew is pointing out that we are not supposed to run everything on general node pool. There are two more node pools, one for specified for accessing data and one for performant computation. So we need some way to use them accordingly to what our coroutine is doing. So here we are needing some way, Andrew is thinking loudly, to pass information from the coroutine to the dispatcher. Is this such a way even existing? You probably will know, because you remember that one of the titles of this talk is abusing the health out of coroutine context. So the way to solve this is actually to create yet another element of coroutine context. This time it is simple enum. We are creating enum node kind that is describing on which kind of node our code should run. Is it general node? Is it data access? Or is it some computation? Here we have some standard context element stuff, nothing important. And right now we can plug it just into our dispatch function. So we are checking here if our context contains some node kind. If it's data, we schedule it on data node pool. If it's computation, we are using computation node pool. And in else case, which in this example means that it was general node pool or there was no node kind specified at all, so it was no here, it will run on general node pool. And here we can do things like this. So we are running coroutine on our dispatcher, and here we are passing to this launch computation as our node kind, so we are sure that this intense computation will be scheduled on some node that has performant computation, and if we are doing some async code that is accessing data, we are sure by passing this node kind that it will be scheduled on something that has easy access to data. Okay, so Andrew has one last question for us about main dispatcher. Because when he was writing programs for Android, yeah, Android is still a thing in 23rd century, and it's still programs for it are written in Kotlin, apps, I mean. There is something called main dispatcher. It is also present in all technologies that have UI, so for example JavaFX, and it is only dispatcher that allows us to access the thread from which we can modify the user interface. So it is present in all of this, and we probably want our clients to also see some feedback, visual feedback, and some information on user on UI. So we need to access some thread that is using this UI. So could we write our own, create our own main dispatcher? Of course, yes, we can customize Coroutine as we want. So you are checking the specification, what your clients are using as a UI tool, and you see SWT. You are for a moment wondering what SWT is, and you remember that is widget toolkit that was used in early 21st century and even in 20th century to write UI for Eclipse IDE. And probably here you expect some joke about how SWT and Eclipse was so awesome that humanity was not ready for it in 21st century and it gained popularity later. But no, it's not about that. I just wanted to show you that the principles are the same even if you are using your coroutines on some futuristic supercomputer, or if you are just scheduling them on some very obsolete UI technology. So, to answer Andrew's question, to write main coroutine dispatcher, you are extending abstract class main coroutine dispatcher, which is extending coroutine dispatcher, and it still has not implemented this dispatch method. So here you are writing implementation for it. You just do it as SWT stuff, so you are getting default display, and using this display you are doing some asynchronous execution of this block, and yeah, this dispatcher is ready. So now Andrew is asking, is it all? Is main dispatcher not any special? Is it not exception? Is it all we have to do? And you answer yes, but actually no. Main dispatcher is some kind of exception because it is main. It is global, so it has to be accessible and useful from every place of the application. If you have multiple main dispatchers and you are using some of them in some parts of the code, the other in the other, there will be no main dispatchers, there will be just ordinary dispatchers. So you have to have some global way of loading it and specifying that given application is using this main dispatcher. And you have to do it in 2 steps, really easy. The first one is to create something that is called main dispatcher factory, and it only needs to have this method implemented, create dispatcher, and return just the instance of dispatcher you want to use as main. And then you have to use Java service loader system to put information in your meta-inf that your implementation of main factory is the main dispatcher factory implementation that should be used in your application. This is the reason why, for example, if you are right now doing some Java Xcode using coroutines, you have to include some very small dependency to your Gradle build that is only adding you this dispatcher factory and nothing more. So when you do that, these 2 steps, you can just use it right like this. So you are launching some coroutine, passing here the standard main dispatchers, and you are 100% sure that it will be executed on main SWT thread. So yeah, so you've answered all the question that Andrew had. He is quite glad right now, and you are also glad because you somehow change his way of thinking. For example, he's no longer thinking about coroutines as just a tool to do asynchronous programming. He's thinking about coroutines more as an interface to access different tools to do asynchronous things. He also has some more insight and inspiration in searching for different ways of solving the problem he meets in everyday life. And I hope after this talk you also see some examples, and you have more inspiration and insight that will help you to solve your problems. Thank you.
Thank you very much. Okay, so now to the questions. Yeah, so ladies and gentlemen, you can also rate the talk. We have a kind of a strange situation here because we have two talks and we have missed questions, but I think the first one is for us. So would you promote Andrew after all of it?
Yeah, he's clever boy. He's asking good questions.
Okay. So this is answered, and I don't know if you see something for you, or if you can answer the first question.
Is there any mechanism to cancel a task in between calling suspend functions? You have to, if it's in between suspend functions, so for example, here you have one suspend function, here the other, and between them there is a lot of processing going on. If you are not handling it correctly, so for example, if you are not checking if this coroutine is still active, because coroutine scope has property is active that you can check, there is no way, but every time when there is suspend function inside of coroutine, the coroutine itself checks if it should be cancelled or not. There are some handles, for example, job handle that can be used to cancel coroutine, and when it's encounter and when it's do the first checking if it's active, on when it's encounter any suspend function, it will cancel itself, and it will also gracefully cancel all the scope, all the parent scope and scope that are children to this parent scope of it. Yeah.
So I think that's all for now. Thank you very much. And ladies and gentlemen, please give another round of applause for our speaker.